This is Mrs. Palmer-Quay with the first video for Module 9. In this video, I want to talk about the polyatomic ions. Remember that ions are atoms that have a positive or a negative charge, and that metals typically lose their electrons and become positively charged, whereas nonmetals typically gain electrons and become negatively charged. So to just use our illustration down here, when there's a balance in the number of protons and electrons, the positive charges of the protons then are equaled out by the negative charges of the electrons, and the total charge on the atom is zero. It is neutral. When an atom has gained an electron, so there is one more electron than protons, then it becomes negatively charged because there are more negative charges in total in that atom than positive ones. And if an atom has lost an electron, then there are more protons than electrons, and the result is a positively charged ion. Polyatomic ions contain more than one atom. You can actually see that in the name with poly as the prefix. And these atoms are held together by covalent or coordinate covalent bonds. If you remember a covalent bond, you have a shared electron pair and one electron is contributed by each atom that are part of that bond, whereas in a coordinate covalent bond, both electrons are provided by the same atom, but both atoms in the bond have access to them. The polyatomic ions can have a positive or a negative charge. Most of the ones that we are going to be dealing with have negative charges. There's only one positive charged polyatomic ion that you will need to remember. And these polyatomic ions typically remain intact in chemical reactions. We talked about this a little bit when we were balancing equations, how you don't have to separate out the individual atoms, but you can just take that ion and count it as a whole piece. When we draw the polyatomic ions with Lewis structures, we do typically put the brackets around the entire structure and then put the charge off to the right-hand corner. So here's our hydroxide ion, an OH ion with one negative charge. We have a sulfate ion, SO4, with two negative charge, and an ammonium ion, that's that positive one that you need to remember, which is NH4. It's just ammonia plus one more hydrogen proton. The charge symbols sometimes are written as the number and then the negative, or as we're more conventionally used to it, the negative and the number. Either way will suffice. Naming polyatomic ions, there's just a few special things that you need to know that'll make it a little bit easier perhaps. There are several families of polyatomic ions that have several different ions with the same charge, but with different numbers of oxygen atoms. And so those particular polyatomic ions can be identified by endings of ate or ite, or combinations of hypo and ite or per and ate around the base element name. So for example, over here on this diagram, we have nitrate and nitrite. They both have the same charge, but you see one is NO3 and the other one is NO2. Below that we have phosphate and phosphite. Again, the same charge of a -3, but a different number of oxygen. Then we have sulfate and sulfite. Sadly, there is no correlation between the ions that are called ates and the number of oxygen. The ate just refers to the base name, and the ite has one less oxygen than that base. So you can see that sulfate has 4 oxygen, sulfite has 3. If there are more than 2 ion possibilities with these particular families, then we go on to the hypo or the per. A hypoite, or in case we'll start here with chlorine. So we've got chlorate here, ClO3 with a 1 negative charge, chlorite with a 2 oxygen and still a 1 negative charge, and then hypochlorite, smaller even than chlorite. You can see it only has 1 oxygen, but the charge remains the same. And then at the other end we have perchlorate, 1 more than the base of chlorate, so we've got ClO4. This same pattern of 4 possibilities go with our other halogens as well, bromine and iodine. Another family of polyatomic ions are those ions that can have a positive hydrogen ion added to the base polyatomic ion that obviously will have more than a -1 charge because it's still going to end up being an ion. So it typically is carbonate or sulfate is the other polyatomic ion that we add a hydrogen to it and create a bicarbonate or a bisulfate ion. These also can be called hydrogen carbonate ions. You can just put the words together. And we had that ion present when we worked with baking soda because baking soda is sodium hydrogen carbonate or sodium bicarbonate. It has no charge once it gets to the solid form of baking soda because the one positive on the sodium ion will then neutralize the one negative that's left on the bicarbonate ion. These particular compounds then are another family that we will occasionally work with, but most of the names of the polyatomic ions you're just going to have to memorize. There are no easy rules that take care of other groups. When you form compounds with polyatomic ions, you are making neutral compounds, and since they're held together because there's a charge on the two parts, you name them following the ionic compound rules, even though there are covalent bonds between the atoms in the polyatomic ion, the whole thing is treated as an ionic compound. So don't say any of those number prefixes when you name them. As I mentioned before, the ammonium ion is the only positive ion that you need to worry about, NH4 plus 1, because all of your other common polyatomic ions are negative. When you have to combine these polyatomic ions to make a neutral compound and you have a multiple of some polyatomic ion, then we will use parentheses around that ion before you add the subscript to differentiate between the subscript that pertains to an atom in the polyatomic ion and the number of polyatomic ions itself. Let's work through some examples of compounds that contain polyatomic ions. Our first one is sodium hydroxide. So sodium, that's just the element. We know that's going to have a positive charge when it's in the ion form. These are all ionic compounds, remember, so we're going to have charged particles. Hydroxide is OH, and that just has a 1 negative charge, so you can see that we can just do a 1-to-1 combination. NaOH is sodium hydroxide. It's a neutral compound, and it has been balanced by its charges. Sodium hydroxide is Li. It's a very strong alkaline solution, very, very basic. Calcium nitrite. Well, calcium comes from the group 2 metals, and so it's going to have a 2 positive charge. Nitrite is NO2, and it has a 1 negative charge. And so in order to balance and make a neutral compound, we're going to need 2 nitrites. In order to show that with your polyatomic ions, you use a parentheses before you put the subscript for the nitrites, because we already have one subscript down here with the oxygen on the nitrite ion. So we have to put this second subscript outside the parentheses. And we have talked about this a little bit in our balancing equations, so hopefully this seems familiar. How about ammonium chloride? Here, ammonium is the polyatomic ion, and as a positive polyatomic ion, it will come first when we write the formulas, because formulas always have positive ions and then negative ions. So ammonium is NH4 with a 1 positive charge, and then chloride, that's your plain old chloride ion that we've been using all the time with 1 negative charge. And so again, just like our sodium hydroxide, we can just write these out without any parentheses, ammonium chloride. And finally, ammonium phosphate, 2 polyatomic ions together. Ammonium again is that NH4 with 1 positive charge. Phosphate is PO4, and it has a 3 negative charge. And so we're going to need 3 ammoniums to compensate for that very powerfully negative phosphate ion. So we'll use the ammonium ion with parentheses around it to say we have 3 of them before we write our phosphate. So I think that's pretty straightforward. You just have to memorize the list of required polyatomic ions and then plug them into formulas like we've been doing all along. That finishes what I want to say for this first video.